So for number, let's see, this is number 17, my version of number 17. And what I'm seeing is they're telling me this is an arithmetic sequence. So what I'm trying to do, what's the common difference? So, well, they're really giving this to me in a nice form, so I'm going to do some things. What's my first term? Well, if n's 1, that's going to be 1/6 times 1 minus a half. Well, let's see, I can think of that as 1 over 6 minus 3 over 6, which is negative 2 over 6, which is 1/3. Negative 1/3. And just to check and make sure, see the next one. Let's see. So a sub 2 is going to be 1 over 6 times 2 minus a half. So let's see, what can I do here? I know that 2 cancels out to the 6 and gives me a 3. So that gives me 1/3 minus 1/2, which, well, let's see, that's going to be, let's see, 3/6. So 2/6 minus 3/6 is negative 1/6. So what I'm seeing here is that it's going from negative 1/3 up to negative 1/6, which is a difference of 1/6. And if I look at the slope of that line, the slope of that linear equation they gave me, I can see that's the common difference. Often that's the case. So that's 1/6. I've already figured out what a sub 1 is. Figured out what a sub 2 is. A sub 3, I'd do the same thing. Substitute in 3. What's a sub 3? Evaluate 3 times 1/6, take away a half. Same thing with a 4. So I won't finish that. So what I'm seeing for this one is I got to find a partial sum, because I'm going from 60 with the 61st term to the 120th term. Now I don't know if this is a geometric or a arithmetic sequence. I'm seeing 3n. It might be geometric. Let's see. Let's figure some things out first. Well, what's the 61st term? Well, 3 times 61 is going to be 183, right? And what's the 4th term? Or what's the 62nd term? Let's try that. So 3 times, and I'm going to write 62 just because I didn't really need to do that, but I'm just doing this to figure out what kind of sequence it is. I see it's going to have gone up by 3, so I think that's 186, and it is. So I'm seeing a difference of 3, so I think what's happening, this is an arithmetic sequence, because if I do 3 times 63, again, that's just going to add 3. So I know the common difference is 3. It is an arithmetic sequence. So that tells me I'm going to use this formula here to find the sum. I have how many terms over 2 times the first term plus the last term. Okay, so in this case, the first term is 183. I guess we should find the 120th term. So 3 times 120 is going to be 360. And that is, let's see, I believe that's 60 terms, isn't it? That's a difference of 59. However, I want to count the 61st term. So I think there's 60 terms involved with this. So 60 over 2 times 183 plus 360, and add these two, times it by 30. That should be our answer. So I wrote all this stuff down, and I realized I wasn't recording, so let me step back here. So I didn't know if this is a geometric sequence or an arithmetic sequence. I do know that this is an infinite series because it's going from 1 to infinity. I'm suspecting it's a geometric sequence because I've got this exponent going on in here. So what I did is, let's see, well, what's the first term? Well, if n equals 1, that's going to be 2 times x to the 11th. If n equals 2, that's 2 times x to the 22nd. If n equals 3, it's 2 times x to the 33rd. So it certainly looks like there's some kind of multiplication going on here, not addition or subtraction. So to find that common ratio, I took the second term divided by the first term. The 2's cancel out. Then we're going to subtract those exponents. I get x to the 11th. I can do the same thing with the third term and the second term. I get the same result. So r is x to the 11th. Then I know that since this is an an infinite geometric series, that's the formula to find the sum of that series, that sequence. So the first term divided by 1 minus r, and they're telling us that this sum is equal to 29. So what I did is I set up this formula, multiplied by the 1 minus r, distributed the 29 through, and now I've got almost all the pieces that I need to solve this. I know that a sub 1 is that expression. I know that r is that expression. So in this formula, I can do some substituting in. I can say that, let's see, I can say, what did I say it was? 2x to the 11th. I can say a sub 1 is 2x to the 11th equals 29 minus 29 times the common ratio, which is x to the 11th. So if I do this, let's see, that's going to give me negative 29x to the 11th. I'm going to add this to the other side to get like terms together. That gives me 31x to the 11th. And that's equal to 29, so then I'm going to divide by 31. Then I'm going to take the 11th root of 29 over 31. And I get some decimal number, and that checks. And that's what they're looking for. They're looking for what is x equal to. Okay, so I hope that helps you solve the rest of these problems.